Hi, I'm Abolore. In today's lesson, we want to look at demand function, which is one of the calculative aspects of demand as a topic. But there are other aspects of demand that requires calculation, talking about elasticity of demand and all that. But in today's lesson, our focus is going to be majorly on demand function. So just a reminder, if this is your first time, second time, or third time watching our video, please do subscribe to our YouTube channel, like our videos, and help share our videos to friends and relatives whom this video might be of great help. So without much ado, let's get down to business as usual. Now, demand function establishes a relationship between quantity demanded and the determinants of demand. And determinants of demand, I did a video on that. They are also called factors that affect demand. So basically, we have price of the commodity, we have price of other commodities, we have income of the consumer, we have taste, preference, and habit of the consumer, we have the number of buyers, population, advertisements, festive period, and all that. These are all factors, or among other ones, that can determine the quantity that a consumer is going to buy. So if we agree to that, then demand will be a function of a function of, that means demand will be determined. That means the quantity demanded of a commodity will be determined by the price of the commodity, price of related commodity, income of the consumer, taste, preference, and habit of the consumer, the number of buyers, festive period, and all that. So demand is a function of all these factors. But here, we are going to be playing with the phrase ceteris paribus, meaning that all things being equal. And that means, or what that means is that here, we are going to hold all of the factors constants and assume that only price of the commodity is the only determinant of demand, although price of the commodity is still the major determinant of demand, among other ones. So here, we are going to hold all these factors constant. Then we now have demand, that's quantity demanded, equals function of price. So what you have here is that demand is a function of price, meaning that all other factors have been held constant, meaning that, assuming that they do not exist, meaning that we only have price as the major determinant of demand, or we are considering price as the major determinant of demand. That's what we have here. Now, going back to demand function. Demand function, like I did say, establishes a relationship between quantity demanded and the determinants of demand. So our demand function, which is QD, equals A minus BP. These are demand function. And here we are still assuming that price is the major determinant of quantity demanded. So let's express all these variables. So we have QD to be quantity demanded. QD means quantity demanded. A means autonomous demand. Autonomous demand or consumption, they are those consumption that do not depend on the level of income. That means irrespective of the change in the level of income, their demand remain constant. And the demand of goods that are usually constant are necessity goods. Let's say water, food, and all that. Yeah, those type of goods or services, their demand is usually constant. Whether you have income or you do not have income, you will drink water, you will take food and all that. And that's, let me take you back to 2020. During that coronavirus, they were locked down, and most people, their income were constant. That means were zero, were nothing. They don't have income, but still they were able to afford to buy food, or to eat food rather, to drink water, to have a place to live and all that. So those demands are kind of autonomous demand. That means irrespective of the change in the level of income, price, or other variables, their demand remain constant. So that's autonomous consumption. B means slope. Slope. So the slope of the demand curve, like you all know, is inverse. This is the price region, the vertical axis. The horizontal axis is the quantity region. So the slope of the demand curve is inverse, going by the law of demand. That means the lower the price, the higher the quantity demanded, and the higher the price, the lower the quantity demanded, ceteris paribus. So that's with respect to slope. And with respect to P means the price of the commodity. So the price of the commodity is P. Now, with respect to this negative sign, don't forget, this is demand function. Demand function always will usually have this negative sign, except in an abnormal demand situation. So this negative sign is there because of the inverse relationship between price and quantity demanded. That means price and quantity demanded, the relationship between them is negative. That's why you have this negative sign here. So with respect to normal demand function, this sign will usually be or will always be negative. That's why you have it. So that's with respect to the demand function. I hope that is understood. Autonomous consumption, quantity demanded, B, slope, and P is the price. Autonomous consumption, their demand does not depend on the level of income, price, the number of buyers, and their demand is constant. So now I want to explain the demand function. We have a question that we're going to play with here to help us understand this deeper, or to help us have a deeper understanding of the topic demand function. So this is the demand function of a consumer, 40 minus 5p. QD equals 40 minus 5p. So let's get to determine this requirement. So determine the quantity demanded at the following price level: $2, $5, $6, $7. B, that's one figure. To draw the demand schedule and call for the above. Determine the total revenue at the above prices. So let's get down to doing justice to that. So determine the quantity demanded at the following price levels. Now let's divide the board so that we'll be able to do justice to that. So we have a demand function to be given. Our demand function is given as 40, QD equals 40 minus 5p. That's the demand function for the consumer in question. Then we have to determine the quantity demanded at these respective prices. So when price is $2, so we come, all we're going to be doing now is substitution. So when P equals $2, then we come 40 minus 5 into $2, because price is $2 here. So 5 times 2, that gives us 10. 40 minus 10, that gives us 30 units. Yeah, your quantity demanded will be expressed in units. So the second price, when P is $5, so we have when P equals $5, then we have 40, the same demand function, 40 minus 5 into 5, since P is now $5. Then we have 5 times 5, that's 25. 40 minus 25, that gives us 15 units. And also we have $6, when P is 6. So we have when P equals $6, then we have 40 minus 5 into $6, since price is $6 now. So 5 times 6, that gives us 30. 40 minus 30, that gives us 10 units. And lastly, we have price at $7. So we have when P equals $7, then we have 40 minus 5 into 7. Then 7 times 5, that gives us 35. 40 minus 35, that gives us 5 units. So these are the respective quantity demanded at the following prices. When price was 2, the consumer bought 30 units. When price is $5, the consumer buys 15 units. When price is 6, the consumer buys 10 units. And when price is $7, the consumer buys 5 units. You can see here that the lower the price, the higher the quantity demanded. And the higher the price, the lower the quantity demanded. Ceteris paribus. Definitely, that's what you're going to be having. So that's with respect to the A part of the question, Roman figure 1. So B part, draw the demand schedule and curve for A above. That means for what you have here. So that's 2 things we are going to be doing there. Demand schedule and demand curve. Demand schedule is a tabular representation showing the relationship between prices and quantity demanded. That's demand schedule, and it's a tabular representation. So let's put that on the board. So we have Roman figure 2, demand schedule. Demand schedule. My American friend would say demand schedule, but my British friend would say demand schedule. So that's by the way anyway. So we have the demand schedule. So we have price, because it simply shows the relationship between prices and quantity demanded. So this is quantity demanded is expressed in units. So let's have the prices. These are the prices. We have 2, 5, 6, and we have $7. So the respective units, quantity demanded. So 30 units. We have 15 units. We have 10 units. 10 units. And lastly, we have 5 units. When price is 5 units. So this is a typical demand schedule. So it simply shows the relationship between prices and quantity demanded. That's what it shows. So we're going to be drawing the demand curve. So let's draw the demand curve. So the demand curve, which is also part of the B, Roman figure 2 part of the question. So we have demand curve, demand curve, demand curve. So demand curve is simply a graphical representation of the demand schedules. So this demand schedule, if we want to put it, or if we put it in a curve, then we call it demand schedule. Demand curve rather, sorry. So these are price region, the vertical axis. This is the horizontal, the quantity demanded region, the horizontal axis, and this is the origin here. So let's plot the price with respect to or against the quantity demanded. So what are the prices? We have 2, 5, 6, and 7. So we have 2, 5, 6, and 7. So you are going to be arranging the price as well as the quantity in ascending order. So in ascending order, in ascending order. So here we have from smallest, that's 5. We have 10. We have 15. And we have 30. Hope you all can see from there. So let's plot the price against the quantity demanded. So we have when P is 2, quantity demanded is 30. So we have 2, 30. When P is 5, we have 15 units. When P is 6, price is $6. We have quantity demanded to be $10, 10 units, sorry. When P is 7, we have quantity demanded to be 5. So we join the asterisks. So these are demand curves. So Alfred Marshall called these, let's say this is A, B, C, and D. Alfred Marshall called them demand points. Demand points. So demand curve, like you have seen here, it's inverse. It slopes negatively. That means the higher the price, the lower the quantity demanded. And the lower the price, the higher the quantity demanded. Ceteris paribus. And one thing you also need to know is that A normal demand schedule will give you a normal demand curve, which is usually inverse or it slopes negatively. And an abnormal demand schedule will give you an abnormal demand curve, which is usually positive. An abnormal demand curve is usually positive because I think I did a video on that. That's exceptions to the law of demand. I mean, it's why demand curve slopes positively rather than negatively. And lastly, we have the third part of the question. So let's go about that. The third part is determine the total revenue at the above prices. So total revenue, you need to understand that. How do you get that? Total revenue, very simple, easy peasy. Total revenue, that's the third part of the question. Total revenue is gotten by price times quantity. So price times quantity gives you total revenue. This is applicable, it's standard in all cases for you to determine your total revenue. Just multiply your price times your quantity. It will give you your total revenue. So we're going to be having a tabular representation here too. So we have price, we have quantity, which is in units. This is in dollar, and your total revenue is in dollar too. So what are the prices? Because we are told to determine the total revenue at the above prices. So these are the above prices here. So we have 2, 5, 6, and 7. So the respective quantity demanded also. We have 30 units, we have 15 units, we have 10 units, and we have lastly 5 units. So all we're going to be doing here is multiplication. So 2 times 30, that gives us $60. 5 times 15 units, that gives us $75. 6 times 10 units, that gives us $60. And lastly, 7 times 5, that gives us $35. So this is the total revenue, or these are the total revenue at these prices. So when price is $2, the supplier or producer will make $60. When price is $5, the producer will make $75. When price is $6, the producer will make $60. When price is $7, the producer will make $35. So that's how to get to total revenue. Don't forget price times quantity demanded. So at this juncture, I think it would be appropriate for me to leave something behind for you all to practice with, because your brain loves practice. Like my boss would say, Mr. Bolawe, what did you leave behind for the students as homework? So I was like, oh, kind of, it's good because your brain loves practice actually. So, excuse me. So let me put the homework here. Homework. Kind of a way of saying thank you for come and see me every time I put out a video. I know some people are gonna be like, what's he saying? So homework. So the demand function of this consumer is given as 30 minus 3p. So Roman figure 1, determine the quantity demanded at prices $2, $3, $5, and $7. And B part of the question, draw the demand schedule and curve. And lastly, determine the total revenue at the above prices, at the above prices, at the above prices. So determine the total revenue at the above prices. That's what you have with respect to the homework. This is kind of easy peasy. Just follow what we've done right here and you will get it, because it's good for you to practice, because learning without understanding most times is kind of a waste of time. So when you practice more questions, you get to understand what the concept is all about. So this is for you all to practice with. So what can I say at this juncture? Thank you all so much for your precious time. I really do appreciate. Subscribe to our YouTube channel if you haven't. Like our page, like our videos, and don't forget to share to friends and relatives whom this video might be of tremendous help. So before I leave, I have a quote for you. Every expert was once a beginner. Every expert was once a beginner. So at this juncture, I want to bid you all a farewell. I will see you on my next video. Do have a good one. Bye-bye.